In this example, it says using a table to find conditional probability. So what we have in this table right here, it says the table shows the approximate distribution of votes in Texas' 5 largest counties in the 2004 presidential election. We want to find each probability. Okay, so if you'll notice, going horizontally across, it's given me the counties. And these are my Bush, Carey, and other votes in Harris County. These are all of my Dallas County votes, all of my Terrence County votes, Bexar, and Travis County votes. If I want to look at the Bush votes, then these vertically going straight down, I could add those up, and that would give me my Bush votes, or vertically straight down, that would give me my Carey votes, or others. Well, if I need to know, so sometimes you may be only asked about Harris County, or you may be asked about Dallas County, or you may be asked about Carey votes, or you may have to talk about the total votes. So pay attention to what the question asks for. You may only want to talk about a certain county of votes for Carey, or a certain county votes for Bush, or you may want to know all of the Carey votes total. Just pay attention to what the question asks for so you know what numbers you have to add up. So let's go look at this first question. So I want to find the probability that a voter from Tarrant County voted for George Bush. Now notice that this says that the voter has to be from Tarrant County. Let's look at B part. B part says that a voter voted for John Kerry and was from Dallas County. A part says that a voter is from Tarrant County, for sure, we know that. And we want to know the probability that the voters from Tarrant County, which ones voted for George Bush. B part says that we want to know the probability that a voter voted for John Kerry and was from Dallas County. So in this first one, our denominator, our total, is dependent on Tarrant County. That's it. That's all we want to know about. That a voter from Tarrant County voted for George Bush. So all we need to know about in this particular problem is the total of the Tarrant County votes. So how many votes were there in Tarrant County? We've got 349 plus 207 plus 3. So the total there is 559. Because this one says that a voter from Tarrant County voted for Bush. Well, the way you're going to write that is the probability that the voter from Tarrant County voted for George Bush. So this is a conditional probability. This is that probability of A given B or B given A. Well, this says that a voter from Tarrant County, so this is my total. This is what I'm looking for. So this is the given part. So a voter from Tarrant County voted for George Bush. So this is the probability of Bush given that they're from Tarrant County. This says voted for Bush given that they were from Tarrant County. Now the problem doesn't say given, but that's how you're going to have to read it. Voted Bush given that they're from Tarrant County. So Bush given Tarrant. So Tarrant, there's 559, so that's my denominator. And I'm looking for the Bush voters in Tarrant County, or the votes that came from Tarrant County. So 349 out of 559. That's the probability. So 349 divided by 559, and that answer is 0.624. So approximately 0.624 of the votes. B part says that a voter voted for John Kerry and was from Dallas County. So the probability that the voter voted for Kerry and was from Dallas County. So that's got two things, that and going on. That means I need the total of this whole thing. And I'm just going to go ahead for time's sake and tell you that the total is 3,125. So we've got to add all this up, and the total of all those voters is 3,125. Now, that a voter voted for John Kerry and was from Dallas County. So this is a dependent and statement. So we need the probability of Kerry times the probability of Dallas County given that they voted for Kerry. So the probability of Kerry is, we need the Kerry votes. So come over here and you're going to add up this column. 472 plus 336 plus 207 plus 210 plus 197 is 1,422. and the total is 3,125. So the probability that the voter voted for John Kerry is 1,422 out of 3,125 times, now, the probability that they're coming from Dallas County given that they voted for Kerry. So now my new total, all I want to know is about the Kerry voters. So this denominator is 1422. Out of those Kerry voters, which ones came from Dallas County? So over here, you're going to come over here and you're looking for Kerry and you're looking for Dallas County. You see where those are intersecting? That's your numerator, 336 out of 1422. If you'll notice, these won out, and we have 336 out of the total. Well, if you'll notice this two-way table, I'm looking for voters that voted for John Kerry and came from Dallas County. Do you see where those intersect? Remember a while ago me talking about that A intersect B? That's an and statement. Well, that intersect, where those intersect is your answer. 336 out of 3,125. I'm just going to take my calculator and divide this out. 336 divided by 3,125 is 0.108. Now the next question asks about the difference between determining whether events are independent or dependent. Two cards are drawn from a deck of 52. Determine whether the events are independent or dependent and find the probability. It says in many cases involving random selection, events are independent when there is a replacement, independent when there's a replacement, and dependent when there is not replacement. So, two cards are drawn. I want to select two aces when the first card is replaced. That is replaced, so that makes me know this is independent because the denominator, the choice of outcomes, is not changing there. So I want to do the probability of picking an ace and an ace. Those are independent, so do the probability of an ace times the probability of an ace. Well, probability of picking an ace, I know there's 52 cards in a deck, and how many aces are in a deck? There's 4. So the probability of picking an ace is 4 out of 52, and I'm putting the card back, so now the probability of picking an ace is still 4 out of 52. That reduces to 1 out of 13 times 1 out of 13, which is 1 out of 169, and you can put that in and get the decimal answer. The second problem says selecting a face card and then a 7 when the card is not replaced. So the probability of picking a face card and then a 7 and then a 7 without replacement. Now that without replacement, that makes it dependent because that second probability depends on that first occurrence. So the probability of a face card times the probability of picking a 7 given that that first card was a face card. Now, what is a face card? If you'll notice right here on this jack's a face card because it shows the face. So a face card is a jack, a queen, or a king. So there's 3 in each suit times 4 suits, so that's 12 face cards out of that deck. So the probability of picking a face card is 12 out of 52 times, now, what's the probability of picking a 7 given that that first card that I picked was a face card? Well, if I pick a card and I don't put it back, what's my new denominator? Now, I picked one card, and it was a face card. That's what we have to assume, that we're going to pick a face card. So that probability is 12 out of 52. And once I pick a card and I don't put it back in, that makes my denominator be 51. And what's the probability that I'm going to pick a 7? There's 4 7s in that deck of cards, so the probability is 4 out of 51. And then if you go reducing, 4 goes into 4 one time, 4 goes into 52, 13. 3 goes into 12, 4. 3 goes into 51, 17 times. So I have 4 over 13 times 17 is 221. And when I put that in as a decimal, I get 0.018. Make sure you're using approximate symbols because it's not equals. 4 over 121 is not 0.018. It's approximately 0.018.